Hi, I'm Craig Dunn and I work on mobile developer documentation at Microsoft. In this video, I'm going to show you some of the great new features of iOS 11 that you can add to your Xamarin apps using C# in Visual Studio for Mac or Visual Studio on Windows. Apple added way too much stuff for me to cover everything today, so I've chosen these examples to highlight ways to make your iOS 11 apps shine. First, I'll cover some important tips for every app developer looking to target iOS 11. Then, we'll take a look at drag and drop for iPad. Next up is map kits, improved zoom handling, and finally, Core ML, which provides a foundation for adding machine learning models to your apps. Let's begin with the tips. Large titles are one of the most visible changes in iOS 11. Almost every built-in app has been updated to reflect this new UI, from settings and music to photos and mail. The large type helps provide context to the user, but it shrinks down to a regular-sized navigation bar if the content is scrolled. It's generally only applied to the root view in a navigation stack, with subsequent views using the regular style. Here's the code to implement large titles. Set the prefers large titles property on a navigation bar, and it will automatically apply that for the navigation controller. To prevent every view from using large titles, set the large title display mode to never on the second view controller in the stack, so that it and all subsequent view controllers will use the regular style. The next tip is to update your layouts. The new iPhone X brings with it new issues for your app layout: a sensor housing along the top, round corners that obscure the view, and a home indicator bar that needs some space around it to be functional. To simplify the task of keeping your app's content visible and accessible, use the Layout Margins Guide and iOS 11's new Safe Area Layout Guide. They adjust to both portrait and landscape mode and can be used to keep all your controls inside the safe area. When positioning text or other elements that shouldn't touch the edge, you can use the Layout Margins Guide instead. This makes text more readable and provides padding consistent with the rest of the system. Note that you should still allow scrolling content and background colors to bleed to the edges of the screen, following Apple's human interface guidelines. Navigation bars, tables, and collection views automatically adapt to the correct size. This is a code snippet showing how to use the Safe Area Layout Guide to affect a control's layout constraints. You can use the safe area or margin to position your content correctly. My last tip is to include the App Store icon in your project. The App Store submission process now requires the icon to be in your asset catalog, so Visual Studio includes a new spot in the asset catalog icon editor. You just need to remember to add the image. Let's see some of these tips in action. This basic table view app shows large titles, and notice how it shrinks as I scroll. On the second view controller, I've set the large title mode to never. On this screen, the text view is being sized using the Safe Area Layout Guide and margins. I've added a grey background so you can see where it ends. When the screen is rotated, the effect is even more clear. And here, in the asset catalog, is where your App Store icon needs to be set. Drag and drop is the next iOS 11 feature I'd like to tell you about. It lets users copy data between apps just by dragging. Remember, it only works on iPad though. Here's a simple example for dragging and dropping table view cells containing plain text. To add drag and drop, you implement two interfaces and assign them to delegate properties. For simplicity, both interfaces are written in the same class here. The minimum code to implement dragging a table cell is to first get the contents in the cell and prepare for sharing it with other apps. In this case, we encode to UTF-8. Then, create an item provider. Tell it about the type of data being dragged, plain text in this example, and pass an expression that returns the data via a completion handler. This is what would get called when the drag is completed. Finally, return a UI drag item containing the item provider. iOS uses all this information to manage the user experience for you. To support dropping, we need to add a couple of delegate methods. Can handle drop session lets the operating system know what kind of data our app can receive, such as a simple string. Drop session did update gets called when the user is dragging something over the control to provide user feedback, such as whether the operation is allowed or not. And perform drop gets called after the user has lifted their finger and the data operation needs to be executed. To see all this in action, let's fire up the iPad simulator with this sample app. To start dragging, I just have to hold my finger on a row. Once the drag preview appears, I can move it, either within the current app or to another app. Dragging within an app behaves like a move operation. Dragging to a different app copies the data. Going in the other direction, notice how the drag preview and table view respond as the data is dragged. If we look quickly at the code, notice how it's broken up into multiple files. This is purely for readability. There's nothing special about a file name with +drag in it. Keep that in mind when you're checking out our samples. Moving along to MapKit, one nice feature added in iOS 11 is automatic clustering of pins as the map is zoomed. With a little bit of extra code, data-heavy maps become much easier to read and navigate. We have to touch a few different classes to make this work. The first is the marker annotation view, where a clustering identifier key must be set. Then, when we register the regular annotation type, also register a new clustered view class that will be used for clustered data. The third change is to create a new clustered view class, a snippet of which is shown here. It can be as simple or as complex as you wish, but it makes sense to include a count of the pins that have been clustered together. And finally, in the getViewForAnnotation method, check for clustered annotations and ensure that the clustered view class is returned when required. With all this in place, let's see how it looks. In earlier versions of iOS, data-heavy maps would contain a sea of pins when zoomed out. Now, the map automatically shows the clustered view when required, which animate into individual pins as you zoom on the map. CoreML is next on the list. CoreML lets iOS apps take advantage of pre-built machine learning models right on the device. To incorporate machine learning into your app, first find a model to use, such as those provided by Apple. Then you can compile it into your app, load the model at runtime, and get results almost instantaneously. The code required is minimal. Determine the path for the compiled model, vgg16.mlmodelc in this snippet, and use the create method to load it. To use the model, marshal the required input parameters. This example uses an NS dictionary to provide an input named image. The getPrediction method is where the magic happens. The model will be applied to your inputs, and the results will be returned, often as a dictionary of options with confidence levels for each result. Before the demo, let's start at Apple's website, where you can download some existing models trained to recognize features in images. You can also download model converters. This sample uses one of the predefined models. It lets me pass an image into the VG16 model and see what it detects. And it actually does a good job on this photo, detecting fountain at a 42% confidence level. Now I'm running out of time, and there's still a number of great features I'd like to mention. ARKit, which brings augmented reality to the iPhone. With relatively little coding, you can establish a scene using the device's camera and use plane detection, place SceneKit objects in real-world 3D space. The Vision framework provides its own kind of machine learning, with face recognition, barcode processing, and more built right in. There's the new SiriKit Intents, and recently announced integration between SiriKit and the HomePod. And finally, Core NFC, which allows apps to read near-field communication tags. Today, we've only touched the surface of all the things you can build with Xamarin and iOS 11. You can get started for free by going to visualstudio.com/Xamarin to ensure you have the tools installed, and then visit our docs and samples to try out everything I've shown today. Learn more at Microsoft Virtual Academy and Xamarin University. Thanks for watching.